value will become 25,000 plus 90. So our mixed cost will become 25,090. We have discussed mixed cost. Now we will discuss cost behavior diagnosing with a scatter graph plot. Diagnosing cost behavior with a scatter graph plot. For that purpose, we need a data like we got table of months January, Feb, March, April, May, June, July. Activity level, units per days, like in the month of January 5600 unit produced, in Feb 7100 units, in March 5000 units, in April 6500 units, in May 7300 units, in June 8000 units, and in July 6200 units. The cost is also there, maintenance cost. For 5600 unit 7900 rupees cost incur. For 7100 unit 8500 cost incur. For 5000 unit 7400 cost incur. For 6500 units 8200 cost incur. For 7300 units 9100 cost incur. For 8000 units 9800 cost incur. For 6200 units 7800 cost incur. As well as our fixed cost was 3300. This is a table that is given and we have to see the cost behavior with the help of scatter graph plot. We will use the same equation as you know, y is equal to, as we discussed earlier, or I mean recently, that this is the equation we are going to use. Y will be our maintenance cost, plotted at vertical axis, we will treat this as dependent variable. X, that is activity level, plotted at horizontal axis, it will be an independent variable. Reason, what will be the reason? Because our maintenance cost depends on activity level. With the change in activity level, our maintenance cost is varying. So it will be our independent variable and it will be our dependent variable, that is dependent on activity level. We will be given a scenario like for the month of May, there were 7,300 units produced, on which 9,100 maintenance cost was incurred. First, we have to calculate variable cost per unit for month of May. For that purpose, our formula will be 9,100 maintenance cost minus maintenance cost minus fixed cost. Fixed cost is 3,300 and it will be divided by with activity level. So we will divide their difference with 7,300 units that are produced. 5,800 divide by 7,300. Our per unit variable cost for the month of May will be 0.79. This is the main method to calculate the variable cost per unit. As we are discussing about scatter graph plot, we will draw a graph. As we wrote above, that on vertical axis our maintenance cost will be there, and on horizontal axis our activity level will be there. If I make a graph, as our ranges are for maintenance cost 7,900 to 9,100, 9,800. So I will take 0 as it will be on both sides. 2,000, 4,000, 6,000, 8,000, 10,000 and 12,000. If we see about activity level, it ranges from 6,500, 5,600 to maximum 8,000. So we will write 2,000, 4,000, 6,000, 8,000 and 10,000. Now there is time of plotting scatter graph. If we see in January our maintenance cost was 7,900, that range is almost 7,900 and our activity level is 5,600. If we come here, our 5,600 amount come at this side. At this side our 5,600 amount is ranging and 7,900 is ranging here. if we roughly intersect, these lining will become at this spot. We are placing dot here because this one and this one will meet here. If we go to the second month, that is in Feb's activity level was 7100 and maintenance cost was 8500. If I place 8500 almost here and 7100 is there, I write almost here. So if I meet these points, it will be here. This will be the second point. For third point, March activity level is 5000 and maintenance cost is 7400. So if I see here, the 7400 amount will come almost here at this side. I am placing dot for 6500 here, and the maintenance cost is 8200. Sorry, for March the maintenance cost is 7400 and activity level is 5000. So I place dot here as well as 7400 will come here. If I meet these 2 points, a dot will come here. For fourth month, our activity level is 6500 and maintenance cost is 8200. Maintenance cost 8200 come here and activity level of 6500 will come here. We will meet these 2 points. They will come here. For May, our maintenance cost is 9100 and our activity level is 7300. Activity level 7300 will come almost here, and our maintenance cost will rise to 9100. So we will place dot here 7300, 90, 100. Then comes activity level 8000 and our maintenance cost is 9800. So at 8000 I will place dot and at 9800 I will place dot here. So the range will become here. Now in July the activity level was 6200 and maintenance cost was 7800. So maintenance cost at 7800 will come here and our activity level will come almost here. If I meet these 2 points, they will meet here. Now we have placed all the dots here. There is time of drawing line, but remember how to deal with the scatter graph plot. We need to know what is our fixed cost. Fixed cost is 3300. That will come at this point 3300 almost here. So this area we will use from 0 to 3300 as fixed, and we will start our drawing line from this point. We will place straight line by using scale or by using whatever the helping thing you have. So if we see this straight line is touching some of the dots. We will make a line of the point that is touching these dots. One is this and last line is this. That is touching dots, or line area that is touching the dots. So this area will be called as relevant range. What is the meaning of relevant range now? Relevant range is that area at which our predicted cost and actual cost meet each other. The relevant range shows that our predicted cost and actual cost are same with respect to activity level and maintenance cost. The main purpose of scatter graph plot is that we have to find the relevant range at which our predicted cost and actual cost meet. So this is the area at which our predicted cost and actual cost meet each other. This is the first method of analyzing the cost behavior. And the equation that we will conclude will be y is equal to 3300 plus 0.79 activity level. This is our A plus Bx. We have calculated B, that is our variable per unit cost, A as fixed cost, and Y is our mixed cost. With the change in level of activity, our mixed cost will be varying. And this scenario we have discussed in this plotter graph. Then come the method of diagnosing cost behavior by high low method. It is only a formula based method for diagnosing cost behavior. In it, our variable cost will be slope of line, that is equal to rise over run. In easy words, y2 minus y1 divide by x2 minus x1. What are these costs? These costs are cost at high activity level minus cost at low activity level. Divide by high activity level minus low activity level. How we will find out these values? We will see the table of actual cost that what is the lowest activity level and which is the highest activity level. If I see 8000 is the highest activity level and 5000 is the low activity level. In the same way, what is the cost at high activity level, that is 9800, and what is the cost at low activity level, that is 7400. So these four will become our values for variable cost slope. Cost at high activity level was 9800, cost at low activity level was 7400, high activity level, which is the high activity level, 8000, and low activity level is 5000. 8000 minus 5000, by calculating these you will get your variable cost. And this ratio we will get 0.80. Again your equation derive, that is a plus bx. So a is the fixed cost that was in this table, 3300. 3300 plus b is the per unit variable cost that we calculated, that is 0.80, and x is the activity level that will, with reference to variation, our mixed cost will also be variated or will also change with the change in activity level. To make this concept easy for you, I can say that this is total maintenance cost and this is total activity level. If they will say that calculate the whole 6 months maintenance cost, you can add these, as well as 6 months activity level, you will add these. Put those values here, your answer will be equal to, left hand side is equal to right hand side. Both sides will have equal values. So that means the high low method, at high low level method, our mixed cost will vary same to same as activity level. This was all about today's lecture. I will make you practice of numericals in our lecture number 10. Allah Hafiz.